I'm Allison Duvall from the University of Washington. I'm one of the steering committee members for the SZ4D, and along with George Hilly, I lead the Landscapes and Seascapes Working Group. It's my pleasure this morning to introduce our international webinar speaker, Dr. María-Teresa Ramírez Herrera from UNAM. She received her PhD and completed a postdoctoral fellowship at the University of Edinburgh in Scotland. She has spent time as a visiting researcher at the University of California, Berkeley in the seismology lab. She's currently at the Paleoseismology and Tsunami Laboratory, Institute of Geography, UNAM. Dr. Ramírez Herrera has an excellent list of publications on topics ranging from paleoseismology and tsunami deposits, active tectonics and faulting, and landscape evolution in subduction zones, both offshore and onshore in Mexico and Chile. Today, she will be sharing evidence of large earthquakes and tsunamis on the Mexican subduction zone. Very excited to hear this presentation, and I know you are too. Just a few comments before I turn it over to her about how this will go. So George will be monitoring the chat and will be leading the questions and discussion after the presentation. You can feel free during the talk to either send a direct message with your question to George, or you can even post comments or questions that are more general to everyone on the chat. But we're gonna wait and we're not gonna disrupt the talk, so we'll address those questions and discussion after the presentation. All right, so without further ado, I'm gonna turn it over.
Thank you very much. Good morning to everybody, and I appreciate and thank for this invitation. I will talk about basically, I'm gonna first address some of the results that we have in terms of historical and geological evidence of earthquakes and tsunamis on the Pacific coast of Mexico related to the Mexican subduction. And so without, just a brief summary of what I'm gonna address here. So look at, as I mentioned, historic record, geologic record. I'm gonna focus on the latest findings of a large earthquake and tsunami in 1787. And then briefly summarize what we have in Guerrero, Guerrero Gap, and also the north over here on the Rivera Plate. And so the questions and challenges that we still have to address, and what we propose and strategies and approach to solve them, and what's going on just now and the further work that we need to do. So the Mexican subduction zone, you might know, some of you, so basically it's characterized by the subduction of the Rivera Plate, a younger plate that it's also smaller plate, more similar to the Juan de Fuca plate, young plate with conversion rates is lower than the Cocos plate. The Cocos plate is a more mature plate, and the rates of movement increase from the northwest to the southeast. What you see here are the instrumentally recorded earthquakes of the last century and this century, and basically the areas of aftershocks. And so I'm just gonna point out of some of the most significant events of the last century. The 1932 event that had a magnitude 8.1, and then I will later talk about them. And then the 1995 event that was a magnitude 8.0. And in this chart, we don't, we haven't included here, but in just 3 years ago, in 2017, on September 7, we had a magnitude 8.2 event, but that was an intraplate earthquake. It wasn't a thrust event. So, and what we know from previous studies by Suarez and Albini is that there was an earthquake recorded in historical records in 1787. And they estimated the magnitude as an 8.6 and the rupture length as 450 kilometers long. So that's their estimate. But what I see as a problem here is that it's not only in Mexico, but globally, most of the instrumental data that we have a very short term. So the time record is in Mexico. The Mexican Seismological Survey started only 110 years ago. And the first with one station, and that station was on the Gulf of Mexico. And then the tide gauge data, I mean, that's relevant for tsunamis. Instrumental data go back to 1942. And so we're talking about only 75 years of data. And I'm sorry, I made a mistake. The seismological, the station was in Mexico City, and the tide gauge first station was on the Gulf of Mexico. So I see that this is a problem because we can underestimate the magnitude and frequency of great earthquakes of this subduction zone and also of many subduction zones if we just base our data on the instrumental record. And so what we've done is to look at the original historical accounts. And in Mexico, previous to the Spaniards' arrival, we had already an earthquake mythology. So the Aztecs already described, and they have a god of earthquakes. And it was described in their pictograms as a jaguar. So the Codex Tegeriano Remenexis, so there was recollection of this data, and so we know the Aztec had already a god that represented earthquake, but not only, they had pictographic representation of earthquakes. So this is the pictogram, Olin, that means movement of earthquakes. And based on this, the Mexica people described that they had experienced 8 earthquakes, and the magnitude has been estimated close to 8.1, similar to the 1985 earthquake that we experienced back in that year in Mexico and devastated Mexico City. So that's why it's so important. Then the Spaniards came to Mexico, and during the historical time, the Catholic priests were the ones that took charge in translating many of the codices, the pictograms, but not only, they also recorded earthquakes in their documents and described them, and they changed some of the ways that the Aztecs and even also the Mayas recorded earthquakes. So the earthquake length for the Catholic priest was quantified not by pictograms, but by prayers, and they used paintings like this one I'm showing here that replace the pictograms. And so the names of the earthquakes, they had not only day, but they had names, because the Catholic calendar uses Catholic saints. Like, for instance, the 1787 earthquake was called the San Sixto earthquake. So there is a lot that we can find in terms of history. So we need just to dig a lot also in archives, and there are also some problems that we face with the archives because some of the documents are poorly preserved, and then some of the documents have been lost. And but we have worked with historians and people that can interpret this data because there was they were written in Old Spanish, so it's like reading Shakespeare in Old English. And so we found in the original document the record of this event that is the 1537 event that is called the Year 6 Houses. This wasn't recorded by the Spanish, but by the local people. And that's why they still had these pictograms that they translated into Spanish, into Old Spanish. And they described there was an earthquake, the greatest of which I experienced, says this Dominican monk. And with this earthquake, we were looking also for evidence in the historical records of tsunamis, but we could only find one document that referred to a tsunami, and that was in the Japanese Meteorological Agency that described that Mexico had an earthquake and there was a tsunami that hit the coast of Mexico. And then we found several documents for the 1787 series of earthquakes. The first one was on 28th March, and it happened between 11 a.m. in the morning and 12 p.m. And this document describes a series of earthquakes, the largest of which was the one that occurred on 28 March. And as I mentioned before, that was described as magnitude 8.6. And there was another event on April 3rd with magnitude 7.3. And I emphasizing on this because they both produce tsunamis. And when reading the documents, we found names of places that have changed the name through time. For instance, the descriptions of the tsunami that are beautifully described here. So you can see this one. So basically it says that fishermen were on the coast already living, but they saw the retreat of the sea almost 4 kilometers away from the coast. So the offshore seafloor was exposed, and they could see corals. I interpret this as coral because they mentioned submarine rocks and trees. So I interpret these trees as coral reefs. And they also describe how the tsunami arrived, leaving fishes and also people, unfortunately, were dead and hanging on some of the trees as far as 6 kilometers. They use the old description for distances, half league, which is equivalent to 6 kilometers away from the sea. So we found descriptions of this tsunami and earthquake, and they were described in the churches that were in these towns shown on red. So the location of the descriptions for the tsunami were over here, but also the tsunami went as far as Acapulco and on the coast on Chiapas. I'll show you later in the map. And we use old maps like these ones that you can see here to determine how far inland went the tsunami, for instance, in the port of Acapulco. So these maps also help us to determine how far the tsunami inundated this coast. And So we've been looking at historical records, but we also use geology, and the principles of geology is stated by James Houghton and Leal, both Scottish men. And so the principle of the present is the key to the past really applies here. And we've been, well, lucky enough to be able, I mean, it's bad for the people, but good for science. So we can observe in the last decades, large earthquakes and tsunamis on the coast of Chile and also on the coast of Japan. This drawing by Lagos and Cisternas is really helpful because basically it describes what happens during an earthquake on the coast. You can have coast seismic deformation that produce either subsidence or uplift depending on the if this is a near trench event or near to the coast event. And then a tsunami that transport sediments, this layer of sand is buried later after time, decades, with another soil layer and so on. So what we observed in 2000, I mean, in these events help us a lot. So here I'm gonna focus on this region between Guerrero and the coast of Chiapas and show you the evidence, the geological evidence of the 1787 tsunami. We were an earthquake. We basically wanted to find this, but we, and also predecessors of this event. And this area that you can see in dashes, orange dashes, is the estimated rupture area by Suarez and Albini. And this is the location of the event, according to them. And so these are the most recent historical, I mean, instrumentally recorded earthquakes. Oaxaca, in fact, is an area that has, is really active in terms of earthquakes. They, I mean, I just mentioned the one in June, a magnitude 7.4 that I will mention later again. So we focus on a geomorphic setting that was good for finding tsunami deposits and evidence of seismic deformation. Close to the lagoon that I showed before in the historical map, it used to be named Alotengo, now it's named Corralero Lagoon on the Pacific coast. So we made that transit and we're digging a series of trenches and pits to follow the trace of the tsunami deposits found here. Basically, we use this principle. Brian Atwater was working looking for predecessors of the 2004 tsunami in Sumatra and Thailand. And he described that, in fact, beach ridges are very useful. So you tend to find the youngest events closer to the coast, and then older events farther away. So we did use a similar approach, and here we showing the LiDAR that we had for this zone. In front, there are a series of sand dunes, and behind a series of beach ridges. So we focus on coring and drenching all these areas, and I'll show you what we found. So it was a beautiful sand layer here, another one that unfortunately was not easy to sometimes to photograph, basically because the water table is really high. But it's a really nice flat area with a series of beach ridges that where we can follow this sand layer and another one on the bottom that I'll show you ahead. So we made a correlation of these sand deposits that contain also ripoclast, that is another characteristic of tsunami deposits, and another layer on the bottom that we couldn't find on the front beach ridges. We analyzed them, and then I'll show you later the results. But what also was really astonishing is to find this breach on the beach ridge. This is the evidence that I saw similar evidence produced by the 1960 Valdivia tsunami back in Chile. And so you can see here is the beach. I don't know, you can see my mouse. Hopefully you can see because I'm pointing a lot. And this is the beach ridge and the bridge in between produced by the tsunami erosion. This is a photograph in the field. This is the beach ridge, and then there is a gap. And behind there is a pond that unfortunately we couldn't core because there are crocodiles. So those are some of the challenges that we face. And then, so this is the analysis of the peak further away from the coast. In here and in others, but I'm just showing you this one, we analyzed microfossils to determine the environment at which these soils were formed, and also what we believe was a tsunami deposit. The tsunami deposit is basically characterized by marine diatoms and also marine dinoflagellata, which means these deposits came from the sea. There is no doubt about it. So do this one, that we didn't know at the time, the timing of events. So we use also geochemistry to determine the composition of these sediments and see use some elements that are associated to marine environments to confirm the procedence of these deposits. And so dating with radiocarbon was impossible because, I mean, not impossible, but it's very difficult because the time range, the error when dating with radiocarbon is too large. So we use, because we knew it was a relatively young tsunami, we used lead 210. And indeed, this deposit occurred in 1787, Common Era. And the previous deposit was, for this one, we used both radiocarbon and estimated with 210 lead. It happened in the 1600 plus minus 31 years. So we believe that this deposit is related to the event described in the historical records that happened in 1537. So to corroborate that indeed there was a tsunami inundation as far as the location of the pit that I just showed, we model the tsunami using a more precise topography with LiDAR. And the inundation on this point, where we had the evidence that I just showed, indicates that here the depth of the inundation was 5 meters high. And closer to the coast, the height of the waves were as high as 18 meters. This is similar to also the descriptions that we found in historical records. And then we had another task to describe the coseismic deformation produced here. Because what we see in modern analogs is coseismic uplift. But most, and I will go back later, most of the events that have been measured instrumentally have happened, except from the one that occurred in 1990, close to the Colima and Jalisco coast. Most of them are near the coast. And it is expected that they will produce coseismic uplift. But when you have a near trench event, over here is the model for the rupture closer to the trench, and using the rupture area by Suarez and Albini, we can see that the coastal area can experience subsidence. So we were more assured on the interpretation that we had based on the microfossil analysis, the diatoms that we had there that were indicative of subsidence of the land. So basically the remarks, I'm trying to go fast just to summarize other results. Over here, what we found is the tsunami deposits for the last 500 years in Oaxaca, in the Oaxaca coast, indicate magnitude 8.6 earthquake, probably similar to the predecessor, and also a tsunami. And this corroborates also the historical observations that are recorded in all archives. And so what is more important here is that what we're proving with this is that long fault ruptures can occur near the trench on this subduction zone. And that was something that before was excluded. So this is very important for earthquake and tsunami hazard assessment. So the Mexican subduction zone is capable of producing large earthquakes and tsunamis and long ruptures closer to the trench. So, and then I mentioned before, we have the 1537 event that also produced a tsunami. And we are just cautious, but we believe it could be a likely predecessor of the 1787 tsunami. So we have a 250-year recurrence between those two events. We need more events. We need more data to talk about recurrence times. So next one. In here, I'm just gonna briefly go to the Guerrero seismic gap that has been the subject of more extensive studies in the last decade. And we've been working here for a while. And then first, I just want to point to the attention to the people, because in 1985, there were two events on September 19, a magnitude 8.1 earthquake that hit the coast of Michoacan. And then there was another earthquake on September 20, also in 1985. But what has been missing a lot from the record is to talk about the tsunami. There were two tsunamis during these days. So we interviewed people. In fact, the people of Barra de Potosí have to move the whole town to higher ground because all the houses were flooded. And fortunately, people were able to escape. And so we look at also in Guerrero at historical records, found several events that I mentioned before, like the 1537, the 1787, also recorded in Acapulco, the 1909, and so on. So for this that I'm just matching, we have tsunami deposits, and the 1925 event that is described as a really high tsunami, 11 meters, is questionable, and the reason why is because some authors indicate that there is no record of the earthquake, but there is a record of the tsunami. So it's possible that a submarine landslide that triggered by the ground shaking occurred at the time. So in this course in Guerrero, we've been working on, for those interested in the landscape and the settings that we use, we work on estuaries, mud flats. We produce the geomorphic map to locate the best sites for coring digging. So this is a low marsh. And over here in Guerrero, we found evidence of a large tsunami on the 3400 GRPP at one of the lagoons, Laguna Mitla. In another lagoon, Coyuca Lagoon, we found evidence of 3 probably tsunami events, but not dated. We've been facing problems with the dating. And this coast was habitated since the pre-colonial time. So we found archaeological evidence that were underwater in one of the lagoons. So that's really interesting. And so we need to work with archaeologists also to determine the estimated age of this archaeological site that has been submerged. And for this, just quickly pointing to in Guerrero, we work on this estuary looking for the evidence of these 2 tsunamis, the September 19 and the September 20, 1985 earthquakes and tsunamis produced on this coast. And we found the evidence you can see here close to the estuary, 2 layers of sand. And we dated them, and we are pretty sure this was the produced this sand layer by the 1985. And this one that we weren't sure we could find any evidence, the 1979 earthquake that also produced a tsunami. The approach that we used was a multi-proxy approach using several techniques to determine the source of the tsunami deposits, geochemistry, grain size, diatoms, loss of ignition, etc. So we corroborated that indeed these are tsunami deposits. And then now I'm gonna just, because I have short time now, I'm gonna move to the Jalisco coast. So the Jalisco Colima area basically is characterized by the subduction of the Rivera Plate. As I mentioned before, this is a younger plate, and also with convergence rates with respect to the North American plate is lower than the Cocos Plate. But these coasts had an instrumentally recorded earthquake in 1932. In fact, there were 2 earthquakes, one on June 3rd and another one on the 28th of June in 1932. And also there is the description of 2 large tsunamis on both events. So I will briefly show you evidence of both. And then more recently in 1995, we had a magnitude 8 event on this coast in between Guerrero and Oaxaca. And Colima. So we looked at archives and found photographs, because we talking about 1932, there were photographs of the earthquake and tsunami damage to the town of Cuyutlán. But these photographs are related to the event that happened on the 22nd of June, 1932, with a magnitude, say, 6.9 earthquake and a tsunami that was described with heights of 11 meters. So here we found also photographs that show tsunami scours on the coast, and we modeled the tsunami with the earthquake scenario that happened at the time, the 6.9 earthquake, that didn't match, in fact. An earthquake with magnitude 6.9, we couldn't explain how an 11 meter high wave could be produced at the time. And then we trenched and we found the evidence of this event, the tsunami deposit, and that occurred on the 22nd of June. But also we found evidence of a paleo tsunami that most likely was generated by a similar event, but in the 14th century. So the way we explain this tsunami produced by a 6.9 and the descriptions of an 11 meters is that it might be that the ground shaking produced a submarine landslide, because with a 6.9 earthquake, we couldn't find with modeling a solution to so high tsunami. But anyway, for the June 3rd, 1932 event, that was a magnitude 8.2 earthquake, and that produced a tsunami that we still had the chance to interview people that were kids at the time, and they described the tsunami at Tomatlan, which is a town over here with a river. And the descriptions are incredible because they describe that the tsunami went as far as more than 5 kilometers inland. And Cumming took the task in 1933 to describe the extension of the tsunami along the coast. So we also went and looked for evidence for this event. And indeed, we found the geologic evidence of the 1932 tsunami, also another deposit that was likely produced by a historical earthquake in 1900, and also co-seismic deformation associated with this event, also recorded in sediments. And also we found the sediment record, not tsunami, but only co-seismic deformation produced by an event that occurred in 1563, and also recorded in historical records. So we keep working, and when there is an event, we try to quickly assess the area and make observations. This is very important. But these events in 2012, this is in the Punta Maldonado in Guerrero, where you can see this, the mortality of intertidal organisms, and this event of magnitude 7.4 in closer to the coast of Oaxaca and Guerrero. This event produced co-seismic uplift, but also a small tsunami that we also measured the runoff. And just recently, despite the fact that we were under the COVID-19 crisis, we went to the field 2 days after the event. The La Crucecita earthquake with 7.4 magnitude produced a co-seismic uplift and a minor tsunami. And the reason why it was minor is because the event was very close to the coast. And the second reason was there was a low tide. And the third one would be that there was co-seismic uplift. So this information is now in press. So we still have, and I'm gonna kind of wrap up, questions and challenges. So now we have the challenge of finding more evidence on the Guerrero Gap. Proof if this subduction zone can produce, I think we prove it, large long ruptures near the trench. We prove it with the 1787 event, but we want to know what's going on over here. And because we have a subduction zone that is 1,000 kilometers long, and the evidence are that is capable of producing earthquakes instrumentally measured 8.2, that's for sure, and 8.6 according to geologic and historical records. So we facing, we need to challenges working on the tropical coast to prove this with geologic evidence, and the challenges are related to the preservation of geologic evidence, scarce diatoms, and foraminifera are easily dissolved because they are made of carbonate and diatoms, even if they are made of silica. Many times are broken, but not only in saline environments, they are particularly exposed to chemical and physical processes. There is a solution, DNA, but it's very expensive. So we're using all these tools to solve the questions and dating. Now we introducing, and I think I have very short time. So I'm gonna wrap up here. So we're working with colleagues using GeoSlicer and also producing models for this area. And then I'm not having time now to show you current results, but hopefully these will come soon. So there is a lot of work to do, but we have already results. And one of the things that I'm pointing out now that we need to do, we put a proposal, is to do offshore surveying and coring. We already working on the geomorphology offshore, and so I don't have time to show now, but hopefully in the future. So I just wanna say thank you to all the collaborators, to the people on the Guerrero, the Oaxaca, Jalisco, Colima coast, because they've been very kind, to all my students and co-workers and my faithful companions, Lord and Duty. Thank you very much. So I can entertain questions if somebody has any.
Great, thank you so much for an excellent presentation. I'm gonna let George go through the questions that he's been receiving and have been posted on the chat.
Yeah, thanks, Allison. And thanks again for a great talk. Also, just as a matter of protocol for folks submitting questions, you're welcome to introduce them directly into the chat where I'll try and organize them and then report them out. If you are uncomfortable with sending them to everyone, you're welcome to send me a private message with your question as well. So we've received a number of questions thus far. So the first is, how is the along strike extent of the 1787 rupture determined?
That one that I'm showing here, it was determined by the intensity interpreted from historical records, and that was determined by Gerardo Suarez and Paola Albini back in 2009. So what we did was to look at more historical records, also to corroborate this on all the places that the earthquake was felt, and we found original documents and corroborated what Suarez and Albini already proposed.
Great, thank you. Another question that came in is, other than the 1.5 kilometers of inland inundation, do you have any other results to constrain the rupture extent of the 1537 event?
For the 1537 event, apart from the historical and geological records, we found in this site this event, and we believe, and that's what I couldn't show just now, we believe that it is found also close to Acapulco in Guerrero. So, but we're still dating these events. We went to the field this January, and so we found these recent events. It's probably, again, the 1737 tsunami deposit, and possibly the 1537, let me go back, the 1537 event. It's possible that it is, but I cannot completely assure you of this because we need the days. And other events that happened in the past. We found more events, at least for now.
Great. Oh,
sorry.
go ahead. I'm sorry.
No, go ahead. Sorry.
We have a number of other questions. One is, has work been done to actually look for submarine landslide deposits in the region?
If someone has looked for submarine landslides in the region, yes, indeed. The 15, and I don't have a figure for here, but you can look at this for the reference in 1932, what we call the Cuyutlán earthquake and tsunami. As I mentioned, well, the evidence are of an 11-meter high wave. And, but we model this assuming a magnitude 7.9 earthquake. However, we couldn't explain a tsunami this size with this earthquake. So then, I'm sorry I didn't put the figure, but we look offshore and there is a large submarine canyon, and we look evidence of several landslides, and we use the landslides to reproduce a tsunami generated by one of these landslides, and one of them, using the size of the landslide, estimated the volume, and we model this, and to us this explains the tsunami, a submarine landslide. So this is in this paper. I'm sorry, over here maybe. Whoever is interested, I can send the papers about this, but it's already published. And now we're looking in here in Guerrero. We don't have we use the GEPCO bathymetric data that I'm aware is not the best, but they came with more refined data recently. We published this information already, just this year came the paper. We were in this area also to look at, there's a big submarine canyon over here. We're looking at also at the offshore landscape, and I'm really pointing out that we need to do more work offshore, and there is a big project going on here, the SATREPS, with collaboration with a project funded by JICA with Joshi, and over here they are working mainly on instrumentation, OBS and OBPs, and so trying to find more information about slow sleep events also in the Guerrero area. But to answer your question, whoever that answer, I mean, ask, yes, there's been some work, but I think much more work is needed offshore.
Great, thanks very much, Maria-Teresa. I have another question coming in that's related to basically the generation of tsunamis that might be observed in the far field. And in particular, the long rupture length and large magnitude of the 1787 earthquake might actually generate a tsunami that could be observed in the far field that might reach an area such as New Zealand. Did you look for evidence of this in the far field?
For evidence of tsunami generated in other subduction zones in the Mexican Pacific coast, is that the question?
I think my interpretation of the question is that are there any other records around that time that would indicate that a tsunami generated by the 1787 earthquake might actually reach other locations in the far field?
Oh, that's a really good question. as I know that I am aware of, I think if there was, evidence, it would, just thinking on the directivity of the tsunami, I would think probably in records in Australia, New Zealand, just thinking worldwide, where we could find, because you see this coast is facing to the south, southwest. So what would be the east coast over here? So no, the answer is no. I haven't looked at records over there, but this is probably very important. Yes.
Okay, we also have another question that came in asking you to comment on whether some of the new tsunami deposits that you've identified might be associated with paleo floods.
With, sorry, with what?
With paleo floods.
Paleo floods. Oh, no. No. There is no way they can be paleo floods. You mean in rivers, right? No, because as I mentioned before, we're looking also at diatoms and geochemistry. So we make sure that the sand deposits contain marine brackish and marine diatoms, or foraminifer and marine, and dinoflagellata are marine. So there is no way this can be a paleo flood unless you have only freshwater diatoms. So no, this is a good question, but we have to discriminate that. We have to exclude that possibility, and we excluded that. So to make sure this is a tsunami deposit, we make sure there are several characteristics, not only that it's sand, because a tsunami deposit can be also finer sediments, depends where you find it. So yeah, the question is not, we make sure this is not a paleo flood.
Okay, great. Thank you, María-Teresa. I guess one of the last questions that came in was a general question as to whether or not you compared some of the results that you observed with other subduction zones, and if so, what would those subduction zones be?
If I compare some of the events with other subduction zones, is that the question?
Yes, it seems to be a broad question as to how might some of the results that you observe here along this subduction zone be compared to other subduction zones.
All right. Okay. Well, comparing to the Chilean subduction zone, or with the where I have worked to, or the Japan Trench, there are some similarities and some differences. So yes, indeed, I have compared, and also I have compared with, well, basically with those zones that have in the last decades big events like the Sumatra, Indonesia subduction zone, even with the Cascadia subduction zone there, Japan, Cascadia have many results, and now New Zealand also, these subduction zones. But there are some similarities, of course, but some differences. It would be nice to make a table, and I will take the task to show the differences. And in terms of looking for evidence, there are some significant differences but that's related to finding the evidence. Because as I mentioned, some of the challenges that we face in the humid tropics are problems that other authors wouldn't find in mid-latitudes, like in the Cascadia subduction zone. But I think Brian Atwater was the first to come with nice solutions working in Sumatra. As I mentioned, and I had the chance to talk to him also about this. And he pointed out to the problems they were facing that were similar to the ones we're facing. I also talked to Jan Kwa, that she's in Thailand and she worked with Brian. And so it's good to discuss your work with other people. And that's what I've been doing, discussing my work with other authors that have been working in geologists, seismologists that have been working in other subduction zones. There are similarities and there are differences, but I think what we found just recently is very important, because I think it's like demystifying the belief that great earthquakes and tsunamis do not happen in the Mexican subduction zone. That was a belief. And I think it is important to show that you have to look at longer records, and the longer records you can find only in history, depends on the country. I mean, for instance, Japan has longer records, and historical records, and look at the geologic record. Because if we just base our hazard assessments, earthquake and tsunami, on instrumental data, although modeling is important, instrumental data really important, but we need more data. So that's why, yes, answering your question, yes, I did compare.
Great. We had a couple more questions actually come in. One is, first of all, one of the participants asked if there are any corals that can record the vertical motions.
Are there any
Corals.
corals? Coral reefs?
Yeah, that can record the vertical motion of the coast.
Oh yeah, yeah. Well, what I show in, well, we don't have the kind of corals that, for instance, Kerisi use in Indonesia. These beautiful corals that are used is almost like looking at a tree and the rings where you can see the growth. We don't have that type of corals in Mexico. We have coral communities and coral reefs. And what we seen is exactly what we done and what we just, in this paper that is gonna come, I'm just trying to find the picture. Yes, we used to record the vertical deformation, seismic deformation of the coast. And if I can find it, just quickly show you. Oh, it's okay. So in June 23rd, just the earthquake that happened a few months ago, the way we measure, apart from resurveying sites that were already surveyed, we use the mortality of coralline algae. And over here is a very small picture, but these are corals that are dying because the coast went up. So this, yeah, we're using corals in this respect. But we don't have this kind of big corals to record in the past other events, but current ones, yes.
Great, thanks. There was one last question that came in, and that was kind of the flip side of a question that was posed before. Is there any modeling or evidence for tsunamis that were generated elsewhere in the far field actually impacting the Mexican coast and producing the deposits along it?
Earthquakes that were modeled and happened somewhere else and then hit the coast and produce at the coast. Well, no models that I'm aware of. I haven't seen any model that, for instance, of the big earthquakes that could hit the Mexican Pacific coast. I would think that if there was a huge earthquake on the New Zealand subduction zone, we would probably find something in Mexico, even with the 2011 event, the Tohoku earthquake and tsunami in Japan. Yeah, indeed it hit the Pacific coast, but the evidence were, I mean, very questionable. I didn't work myself on those, but some other authors produced a paper about it, and I don't think they can be permanent because it was very small deposit, if it indeed is a deposit. It was very questionable because it was on the shore, on the beach, and very difficult to distinguish to me. I mean, I think, yeah, the flooding occurs, but not very sure it's being modeled. I haven't seen any model from other authors on remote tsunamis, but it would be an interesting work to do. Yeah.
Great. And then also I'll just leave maybe another 15 seconds, the chat room open in case people had any last questions. I'll keep it open. If any come in, I'll present them.
All right.
Okay, it looks like no additional questions are coming in, so I'll hand it back to Allison for some concluding remarks.
Okay, well, I just want to say thank you so much for a wonderful talk that's been listed over and over again in the chat. That was really incredible overview, and thank you so much. And I also just wanted to note that I also posted this in the chat, but our next international webinar will be on October 9th. This one will be at 11 a.m. Pacific time. Victor Cruz Atienza, by coincidence, also from UNAM in Mexico City. So we look forward to that presentation. We hope you can join us again. And we will thank you one more time, Dr. Ramírez Herrera, for such a fantastic presentation.
Thank you very much.